Hello and welcome to my video lecture series for Cisco NetAcad. This lecture focuses on Lab 7.1.4.9, identifying IP version 4 addresses as part of the Introduction to Networks version 6 from Cisco Networking Academy. Our lecture today will be broken into 5 parts. In part 1 of this lecture, I will cover how to successfully complete part 1, step 1 of this exercise. In this exercise, we need to be able to break down a network address into its network portion and host portion. Each IP version 4 address has a network portion and a host portion of the address, which is determined by the subnet mask, which is a complementary component of each IP version 4 address. As we focus on today's exercise, every time you see an IP version 4 address, you should also be given a subnet mask. That subnet mask might take the form of 4 segments called octets, each of which are numbered between 0 and 255. Or that subnet mask might be in the form of a CIDR notation number, which is indicated by a / and a number which ranges from 0 to 32. This number is also called a prefix. In this assignment, the IP version 4 address and the prefix are given information, and we must calculate the 4-octet version and other information. Let's get started. To start, we need to pick one of our IP addresses to use. I'm going to pick an IP address that isn't part of this exercise so that you can have the full experience of doing all of this work for yourself and get that practice. So the IP address that I'm going to pick today is 192.10.224.128, and we're going to use a prefix of 29 for this example. Okay, so the first thing that we have to do is we need to take this prefix, and they want us to break down the prefix into its network and host components. And they want us to indicate the network and host components where a capital N is indicative of an entire octet of all ones. So that means that the entire octet is in the network portion of the address. So our network bits are indicated by a 1 in our subnet mask. And a capital H is indicative of all 8 bits in that octet of my subnet mask being representative of a host bit in my network address. And our host bits are represented by the number 0 in our subnet mask. So how do I do this? Well, the first thing that you want to do is you want to convert your prefix or your CIDR notation into those 1s and 0s that are represented in your subnet mask. And the really awesome thing about a prefix is the prefix simply gives us the number of network bits that are in our mask. So what it's telling me for this /29 is that I have 29 1s in my subnet mask. Now, every subnet mask that you're ever going to see is 32 bits long. So that means 32 minus 29, I should be expecting to have 3 host bits, because that's what's left over after I have 29 network bits. Every part of my subnet mask has to be either a 1 or a 0. It has to belong to the network or the host. Can't belong to both. Okay, so how do I write this out? What I'm going to do is I'm going to start by putting 29 1s And I'm going to break those up into 8-bit groupings, which are our octets. So that keyword oct says 8. Okay, so I'm going to say, here's my first bit, second, third, fourth, fifth, sixth, seventh, eighth. I've got a full octet, so I'm going to put a period there to indicate the division between my octets. Here's bit number 9, 10, 11, 12, 13, 14, 15, 16. Again, that's 8 more, so I'm going to put another dot to end that octet. Then I'm going to put 17, 18, 19, 20, 21, 22, 23, 24. Another period to end that octet. Now we're in our fourth octet, 25, 26, 27, 28, 29. And then, as my calculation showed, I have to fill out the rest of that octet, those last 3 bits. There's number 30, 31, and 32. So that is what my subnet mask looks like. Now, the activity wants us to indicate a capital N if an entire octet is filled with ones. Okay, so I'm going to, in my activity, this is going to be a capital N, and then a dot, and then this octet is entirely one, so it's going to be represented by a capital N. And then my third octet is also all ones, so I'm going to represent it by a capital N. And then we get to our fourth octet. And in the instructions it says that it wants us to place a lowercase n if a single bit is in the network portion, and a lowercase h if we have a single bit in the host portion. So this last octet, because the octet is mixed with zeros and ones, this one I have to use lowercase letters. And so this one I'm going to have an n for every bit that is a 1, and I've got 5 of them, so I'm going to draw 5 n's, and then I'm going to put, for my host bits, I'm going to put a lowercase h. So 1, 2, 3. All right, that is going to go into my first column of the information that I need to fill out about this activity. Now for the second column. For the second column, we have to take this subnet mask, those zeros and ones, and convert that back into decimal numbers. So if you remember from your lesson when we did decimal number and decimal to binary conversions, we can convert these blocks into 4 numbers that range from 0 to 255. Now, if an octet is entirely filled with ones, then that is the biggest number I can have, and so that is going to be a 255. Okay, so each one of these octets that is filled with ones that had a capital N, that capital N is just a 255. So I've got 3 that are 255. Now my last octet is the one that I have to calculate. Whichever octet had mixed bits, I had zeros and ones in that octet, is the one that I'm going to have to actually calculate. If my octet had all zeros and I had listed it with a capital H, then the result is a 0 because that's the smallest number I can put in a byte of information. Okay, so this last octet I've got to actually calculate, and so I'm going to use my little shortcuts where I add up each one of the numbers to the place value that each one of those ones represents. And so my first bit right here, that is the place value of 128. So I'm going to put 128, and to that I'm going to add the next place value. That next place value is 64. And then I have the next place value, and that place value is 32. Then my next one is 16. And next I have an 8. When I add all of those numbers up, I will get the result of 248. Alright, so that 248 is what I'm going to put as the 4th octet for my subnet mask column. And so this is going to go into my subnet mask column. Now for the final column of this exercise, we need to calculate the network address. Now the network address, some people think that it's a really hard thing, but it's really not hard at all. What you have to do is you have to take your IP address, that's the actual first 4 octets that you had, and go through a process that we call ANDing 2 numbers together. And the number that we're going to also AND together to determine what our network address is this subnet mask. Okay, the process of ANDing is when I take 2 numbers, and those 2 numbers, because we're in the binary system, they have to be either a 1 or a 0. Okay, so let's think about the possible combinations of 2 numbers, 2 individual numbers, that can be a 1 or a 0. So for my first one, I could have a 0 and a 0. I could have a 1 and a 0. I could have a 0 and a 1. Or I could have 2 1s. So there are 4 possible combinations of the numbers 0 and 1 when I have 2 that I need to combine. So the process of ANDing, A-N-D, is a term that we will use a lot in computer science. It's a concept from our electronics, where in electronics they have ANDs and ORs and NORs and NANDs, all kinds of great stuff, but let's focus on the AND process. Okay, so if I have 2 numbers, and those 2 numbers are 0 and 0, and I AND them across, what my resultant set is going to be, or my result is going to be, is I'm going to get a 0 when I AND together a 0 and a 0. If I AND together a 0 and a 1, and the 0 and a 1 represents true and false. So if I have something that is true and something that is false, it wants to know, if I AND those together, is it going to be true or false? And so that answer is false in the AND world. And so if I've got a 0 and a 1, my result is also going to be false. The only time that you get a true is when you AND together a true and a true, or a 1 and a 1, and that gives us the number 1. Okay, so to do this ANDing, first thing I've got to do is I've got to convert my IP address into its binary form. And so the binary form of 192 is 11000000. I'm sorry these squish all together, but I was trying to fit zeros in the same space that a 1 fits. Okay, so then for my 10, I'm going to convert it, this 10 up here. So that's a 10, a decimal 10. I need to convert it into its binary form. So a decimal 10 is a 0, 0, 0, 0, 1, 0, 1, 0. Okay. My third octet, I have 224. So for my third octet, I'm going to convert it, and I get a 1, 1, 1, 0, 0, 0, 0, 0. Okay? And my last octet, which is 128, That is a 1, 0, 0, 0, 0, 0, 0, 0. Okay, so now each one of these 32 bits, I've got 32 bits in my IP address and in my subnet mask. Every bit I need to convert, or I need to do this AND process for. So I'm going to compare this bit to this bit. That's the first bit in my IP address to the first bit in my subnet mask. And so if I'm comparing a 1 to a 1, then according to my charts, I get a 1. So I'm going to put my result here. And this result is my network address. Okay. So, top row is my IP address. My second row is my subnet mask. My third row is my network address. So my second bit, if I look at my second bit, in both my subnet mask and my IP address, there's a 1 and a 1, so I'm also going to get a 1. And then my next is a 1 and a 0. That's going to give me a 0. And if you look, I've got a 0 and a 1, a 0 and a 1, a 0 and a 1, just across as I look at each one of the rest of the bits. And so all the rest of these bits are also going to be 0 in this octet. So we're going to fast forward here. Alright, and need one more 0. There we go. And there's my octet marker, a period showing the separation of octets. Okay, next octet. I've got some more 0s and 1s here, so those are going to be 0s. 0 and 1, 0 and 1 gives me a 0, 0 and 1 gives me a 0, 0 and 1 gives me a 0. Here's a 1 and a 1, that gave me a 1. And then another 0 and a 1, 1 and a 1 is a 1, 1 and a 0 is a 0. Okay. Third octet, same thing. 1 and a 1 is a 1, 1 and a 1 is a 1. Third bit, 1 and a 1 is a 1. Then bits number 4 through 8 are all going to be 0s because I've got a 0 in my IP address. So fill in the rest of that particular octet with 0s. Okay. Now my last octet, we're going to do the same thing. We have a 1 and a 0. Yay. That gives me a 1. A 0 and a 1 gives me a 0. 0 and 1, 0, 0 and 1, 0, 0 and 1, 0. Now I've got 0 and 0. According to my chart, a 0 and a 0 also gives me a 0. So here we go, 0, 0, and 0. Okay, so what this does is this now is my network address in its binary form. So we're going to convert that back into its decimal. Okay, so converting this network address back into its decimal form, this first octet is 192. My second octet is 100 and, nope, it's not 100. It is 10. Wow, look at your numbers. Alright, so there we go. Okay, my third octet, I've got 128 plus 64 plus 32 will give me a 224. And then my last octet, I have 128 plus nothing. So that is 128. Okay, so this number right here is my network address. Now if you take a note on this one, you will notice that my network address for this particular case is also the IP address that I started with. We'll talk about this in another section, but this is a special address because this is a network address. Is my 192.10.240 or 224.128 in the 29-bit subnet mask.